That could happen to you too, so I thought I'd show it. So today I'm going to play with my 3D printer again. Done a video previously, well, done a few videos previously on 3D printers, and this particular one is the Ender 3 V2. I've had this one for, I don't know, probably a couple of years now. I did a video previously showing the dual Z upgrade on this. So I actually put two stepper motors on it. So you've got the original stepper motor over here. I added a second one on this side. And this actually worked quite well. Now I did show some things about setting up the axis and stuff properly and making sure all the alignments are right and things aren't pinching and tight and twisted, and how to get everything all aligned nicely. I did show that in a previous video, so I'll probably link it in down below or up there or something, and make sure you check out that video as well once you finish watching this one, because it'll tell you some tips about how to set this thing up properly. So as you can see on here, there's the original stepper motor. Here's one I added on. Here's the bracket which I had to change. You've got another lead screw just here, which also attached at the top to stabilise it. And this has worked really well. Now the only tricky thing, when you've got two stepper motors in parallel, they could potentially fight each other a little bit. I haven't had no problems with it. And obviously one thing you'll need to do is, because you could potentially turn one and not the other one, you can see that one's turning a little bit anyway, but you can see the gantry twisting a little bit there. So when you're setting this up initially, you need to make sure that these heights, like each side, match. I'll cover that in the previous video. Now what I want to show this time is a slight modification to this setup, which is another way you could actually do the same thing with dual lead screws. It does allow for that. There's a couple of different kits you can get. Because I already had the lead screws set up on this side with the stepper motor, I've got a more basic kit this time. But you can get ones which have got lead screws with them as well. What this is another way of doing the dual Z effectively. Instead of having two stepper motors, you still only have one. But what you do is you put a pulley on each lead screw. So you put a pulley on this lead screw, you put a pulley on this lead screw up the top, and then you join them together with a belt. So that way this stepper motor is then driving both lead screws, so it's raising and lowering both sides of the gantry at the same time. Now obviously you're going to get a little bit of losses in that, and you might get a little bit of twisting, like a bit of stretching the belt and that sort of stuff. You may still get a little bit of wobbling in your axis, but it's still going to be far better than only having a single lead screw, because this tends to lag behind when you've only got a single lead screw. This will tend to pull down or go up depending which way you're going. It does wobble like this, which is why having a dual Z axis is a good idea. What I'm going to do is combine the best of both worlds, hopefully. So I've got dual motors. Now the trouble with dual motors is that if this goes out of whack and it starts being on a bit of a lean, because you turn one manually by a little bit, for example, and it's changing axis, it will stay that way. Right? Which is why I wanted to put the pulleys on this with the belt, and then I can set the horizontal of this and make sure that, because of the pulleys and the belts being tied together, it ties the two together, and that way they'll always stay in sync and it will always stay dead vertical. Now I've actually had no problems with this setup. It's been fine. I haven't had any issues with it, but I thought I'll do it anyway because it's easy to get this wrong. If you accidentally knock it or lean on one side or something, you could potentially move one, then you can end up with a wonky gantry and can have print problems with alignment, stuff like that. So it's better just to do that and then tie it together. But this is one kit. So there is another kit which has the lead screw as well. Let's say it does have a bracket with it, which is the same as this bracket basically, except it's actually longer. I don't know why they need to have a longer one, but because this one actually does exactly the same thing. The only difference between this one is got an extension and a little hole in it, so you can get an Allen key through to do that cap screw up, which kind of makes no sense to even have that length bracket. But anyway, it does exactly the same as that, so I'm not going to cover that again. I showed that in the previous video. The other thing that's got in here is a tensioner, belt tensioner. So you attach this to the axis. I'll demonstrate on this one. It's obviously not the way it goes, but it goes in the top beam. You'll see that later on. And it will go across there like that, and so it's a tensioner. You just adjust this, and that'll adjust the tension on the pulley on the belt. So you take all the slack out of the belt. That way it helps keep it in sync. So it should be pretty straightforward. Let's get into it. Now obviously in here you can see I've got the brackets up top of the lead screws, stops them wobbling around. Right, kind of holds them in about the right place. And I also show how to set all these up in positions and stuff when I did the previous video. I showed all that then. So you know exactly how to get it all aligned so it's not trying to fight each other and that sort of stuff as it comes up. So I need to get these lead screws out so I can get these pulleys on. And so we need to loosen off the top cap screw on this one. It's really tight. Hasn't been undone in a while. Stop it pinching. That might allow it to pull. Yeah, that's enough. So I can wind that one out. There we go, that's winding out. So now I'm going to put the pulleys on. I'll do this side first. So it's already apart. I'm going to slide that through. That should just basically slide in. Now I'm going to wide this through this brass footing at the bottom there. Wind it right down. That should go straight into the motor. Okay, so we've got one pulley on here. That's now tied into the stepper. I can now tighten this one up. It's definitely right down. So we'll tighten this one up. I'll try and get the steppers pointing the same way as well, probably. Make it easier to get the nuts, but and make sure this one's still tight as well in case it's vibrated loose. No, that's still good. So that's that side semi done. So now we've got the pulley at the top. I'm not quite sure about the exact height I need to put this at, but it's going to be up here somewhere. I'll just put it roughly there for now, just one done up. Then we'll do the same thing on the other side, basically just fit the pulley on the other side. Undo the motor. That should wind out. Get the pulley on there. Put it back in. I forgot to do something. I forgot to put the belt on. So I actually need to put this belt on the same time I put these pulleys on. So I'm going to take these bottom bits back out again, pull the threads back out, stick the belt around the threaded rods, and then put it back together again. Yeah, I'm an idiot. That could happen to you too, so I thought I'd show it. Alright, so now we're ready to put this together. I've got the pulley on the top here, you can just see it in the shot. Got to put the belt on. Let's go around that, and then we can thread this back through again. But you can see there, the pulley will go like that. I've got to replicate the same thing on this one. Let's put the belt on, put it back down again. Make sure they're both tight, just in case it's come loose from time. No, that seems good. So I was running it up to the top, the belt's on there like that, you can see it's really loose. Right, that's why it needs a tensioner on there. That's the whole point of the tensioner. I've got to figure out exactly where to put the tensioner yet. I don't even know what height it needs to be yet, so we need to look at that stuff. There's a tensioner, and it's actually got a tooth bit on it as well, so that means it must only be pulling or pushing on one side. Now I'd rather have it pushing towards the back, but that's not going to do it. So it means I'm probably going to have to be pushing towards the front. Right, so it probably needs to be something like that, pushing forwards. This will need to come up small as well, but that should be alright. Got heaps of adjustment on that belt there, loads of tension adjustment. So let's mount this on there. So there's tensioner, here's the hardware. So bolt from the bottom, got these little T-nuts. Yeah, it goes that way up like that. And there's the pulley. Repeat the same for the other side. Alright, let's mount this on. Now the idea of these little T-slot nuts is that you put them in sideways and they go into the channel, go along the channel, and then they turn and lock in. I'm not going to worry about hooking the belt on yet because I'm going to adjust it anyway. The first thing is to get the T-slot in and turn it, and it should lock in. Sometimes you need to give them a bit of wobble around to get them in the right place. So let's put the belt on like that. Now this pulley needs to be lifted up a little bit. I need to make sure it's all in alignment this way. So this one's got to come up. Try and just eye it so it all looks about right. So it all looks basically the same level across the same way. Of course you probably couldn't just measure it, but eyeing it is probably good enough. Now I want to spin this one around a bit so I can get it in. Get the both cap screws, or grub screws. And the same deal, try and eye it up so it's all in line. Okay. Looks kind of straight, maybe. Hard to tell until it's in tension. So it's slightly low. Lock that up. Just gently. Don't want to damage the threads on this thing. You may need to make sure you don't overdo it. Shouldn't take much. Now that should be sitting there nicely. And we shall put this in the middle roughly. In the middle is just more aesthetically pleasing. I mean, you could stick it to one side if you really wanted to. Could put it to one side, but I think in the middle is going to be better. And push some tension on. And tighten those up. So that should be enough tension. Doesn't need much tension, surely. And that will lock them together. So if you turn one, the whole lot turns together. Right, it doesn't matter which one you turn. it means they're going to stay in sync. I've done this, but I need to make sure the gantry is now level. So what I'm going to do is I'm just basically going to measure it off the bed to try and get it parallel. The bed is basically level, I know that much. Although I could check it from parallel from these vertical parts as well, potentially, but this side's a bit tricky. But maybe you could do that as well. But we want the thing to be level relative to the bed. You can choose this, you just set this to any height you want, obviously, right? But I'm just going to 70, because that's a nice, easy one to see there. We'll line up to 70 like that. Okay, we can see the 70. A bit closer. Right, just see the 70 there. Right, get it so just like that. And then I'm going to move the carriage across and measure the other side. And see if we're on 70 as well. We're really close. So 70 there. Just see it there, just cutting off. Repeat it over this side. And we're slightly higher there. So it's just a fraction out of alignment there, which isn't surprising considering what I've been doing to it. It's like so dusty my roller is. So that's alright, it's easy to fix that. What we can do is loosen off one of these pulleys at the top, give it a slight turn to raise this side very slightly. We're going to do it that. Now I need to turn this so I can get to the grab screws on the pulleys. So let's go to where I can get to both of those and get to a mark just below the 5 maybe. We can get to that one. Just going to loosen the grub screws off on the pulley, just on one side only. Don't forget, because that's tying the two together, so they're working together. So if I now adjust this very slightly to bring it up, just a little bit, like that, not much at all, and we'll tighten the grub screw back up again, just one of them, and then we'll retest. Okay, let's recheck that. So same deal, just getting the mark just appearing. See that? Move it over, do it on this side, and the mark is just appearing there, looks of it. Okay, obviously the further over you got it, the better. Probably can go a bit further over. And the same deal, mark is just appearing. So that is now level relative to the bed. But just to be sure, I can show you this. I'll put this on here. We can check the vertical alignment against this beam here. Alright, try and get it so it's on axis to the camera. Alright, so you want to make sure it's actually a right angle. There you go. So, yep, frame's a right angle. It's all good. The important thing is the bed is level in relation to the nozzle movement, right? So wherever the nozzle goes on the bed has to be level to that. So even if everything's wonky like this, as long as the bed is the same wonkiness, it will work. But then if you're doing something which is quite tall, you might find that you get distortions on your model when you're printing. So if you get everything square, then you're in a much better position to get a decent print out of it. So right angles in here, which means this is square to this. I know these are square to the base because I did all that when I assembled the thing in the first place. So now we've squared off the bed in relation to this. And I've also checked it right across the whole bed, front and back, to make sure that this isn't slanting in a way like that. I had it really tuned in anyway. Each time I was doing a print I was just tweaking these knobs just a little bit on the bottom just to get a nice even bed, because I've actually got a glass bed on this as well. So I've got a magnetic on top, glass underneath on top of the aluminium. Aluminium plates are never flat, they are never flat. So don't base it on the aluminium plate, especially when you're heating and cooling the bed. Actually it can warp. Different cooling rates and different heating rates, stuff like that, you can actually bend it slightly. It's impossible on CD printing. But put a glass bed on top, which is what I've got here. Even though I'm not using a glass bed, it's on there purely to get it dead flat. And then I've got the magnetic on top of that. So I've got a few layers. It makes it a bit heavier, it means I can't print quite as fast, but it's flat. And I've got a convenient top on it to take off as well when I want to get the print off. Anyway, that's all beside the point. Subscribe if you're not already subscribed. Other videos to watch down below. I do a lot of electronic repairs. Maybe you're interested in those, maybe you're not. I've got a collection of 3D printing videos too. I'll probably link those. If you're interested in becoming a patron to help support the channel, there's a link over there for that. Right there. Catch you later. Oh, I forgot to do this, but let's put that bit on.